Good evening and welcome to the first ever Tennessee Virtual Star Party 2.0, featuring telescopes from the backyards of astronomers all over the state of Tennessee. I'm not kidding, y'all. From Kingsport to Christiana, which is just south of Murfreesboro, to Dyer Observatory in Nashville, to Cookeville. Yes, Tennessee Tech University has gotten in on this, all the way out to Memphis. We have a great show for you tonight. Now, I do have to give a little disclaimer. On the actual night of the Star Party, which was July 24th, we did have some technical difficulties. And so we're kind of coming back and giving you a new introduction, giving you some more information so that you can enjoy the Star Party a little bit better. And I also want to make sure and kind of give some credit to a lot of people who had a lot to do with this Star Party. So one group we want to mention is Friends of Warner Parks, which is providing our Zoom meeting space for tonight. Yes, our astronomers are all in their own little Zoom bubbles, and they are shared with my friend Theo Wellington's help. She's providing all of the technical assistance along with her son Nathan during the Star Party. I also want to thank Metro Parks of Nashville-Davidson County. They are providing our meeting space for the virtual Star Party. And by the way, they host Star Parties all over the city of Nashville at Shelby Bottoms and at Bell's Bend. So make sure and check those out in the future. I'd also like to thank Pink Palace Museum of Memphis. Thank you, Dave Manis, for the work that you're doing out there. Bays Mountain Park and Planetarium in Kingsport, Tennessee. Thank you, Adam Fans, for the views of Jupiter and Saturn tonight. So you better stay tuned for that. I want to thank, as I've already mentioned, Tennessee Tech University. Dr. Steve and Dr. Mary are going to give us some great views of some nebula tonight. And I also want to thank people who are kind of just doing this on their own. We can't forget John Kramer down in Christiana, who's taken a minute as an amateur astronomer to share his backyard telescope, as well as Jeremy Veldman of the Memphis Astronomical Society, who's going to give us some really great information about astronomy in your own backyard and some really cool things that you can do with a telescope in your own backyard. I don't want to forget my new great friend, Dr. Billy Teets at Dyer Observatory. Now, this is what's super cool about Billy. Y'all, he has big plans for this whole Star Party business, and he's really expecting to offer more virtual Star Parties in the future. So while you can't get up to Dyer Observatory in Nashville, you will be able to see what he's seeing through that awesome telescope very soon. And by the way, he'll be looking at the moon here in just a moment. Now, while you're outside, if you're like me and enjoying this Star Party from your phone or from your laptop, I want you to take a moment and listen to what's going on around you and smell the summer air. Or maybe it's a different season now that you're watching this on YouTube. But be aware of your surroundings. And right now, we still have Comet NEOWISE in the night sky. So find the Big Dipper, find the handle, and kind of look to the left of the handle. Maybe you've got a clear sky tonight. Maybe you've got some binoculars. Go out there and try to take a look at it. Guys, there's lots going on right now that we're not only going to miss when December rolls around, but also we're going to miss in the future. These are once in a lifetime things that you can enjoy. I hope that you enjoy the Tennessee Virtual Star Party. Please patronize our various sponsors, as well as the planetariums that are taking part in this. And get outside and enjoy the night sky on your own. Enjoy the show.
Well, thank you everyone for joining us this evening. I'm Dr. Billy Teets, and I'm the acting director and the astronomer for the Vanderbilt University Dyer Observatory. We're located in Brentwood, Tennessee, which is a few miles south of the main Vanderbilt campus, but we've been pointing our telescopes to the skies since 1953. Now, of course, because of the pandemic, we are closed down for in-person events here at the observatory, but we are trying to continue our education and public outreach mission by doing virtual events such as these. So hopefully we will be able to do these on a monthly basis. But make sure to check out our website, which is dyer.vanderbilt.edu. We'll be posting updates about upcoming events that we have virtually. And once things start to improve, we hope to be able to reopen, and we'll be posting any updates about in-person events that we'll be doing. So right now we're just doing virtual events, but also be sure to check out our social media, Facebook, Instagram, Twitter, with the handle @DyerObservers. So tonight we're going to be focusing on the moon. So here we have a wide field view of our moon. This is actually with the camera that is attached to the finder scope of our main telescope, what we call the Kingsport telescope. And we get a really nice view of the moon right now. The moon is currently in what we call a waxing crescent phase, which means that over the course of the next few nights, the moon is going to be getting more and more illuminated. And one thing to emphasize is that we are seeing the near side of the moon. The other side of the moon that we cannot see from Earth is called the far side of the moon. And a lot of people think this is the dark side of the moon. In reality, there is no dark side of the moon. In fact, during this phase, we see about 25% of the near side of the moon in this nice waxing crescent, but about 75% of the far side of the moon is illuminated. Now, when we are talking about basically this full area of the moon, we call that the face of the moon. Some people refer to it as the disk, but when we say the face of the moon, we're basically saying the full surface of the moon that we can see. Now, we'll also be doing a little bit of other terminology. For example, when we refer to the edge of the moon, as I'm highlighting here, this nice curved edge, looks like a very sharp edge, that is what we refer to as the limb of the moon, L-I-M-B. So the edge of the face of the moon is called the limb, and in our view here, the limb looks like it's pretty smooth. But if you have a small telescope, and especially if you magnify the view of the moon, you'll see that it is actually very rough because of the mountains. Now, the other area we're highlighting here, this is the apparent day-night edge on the moon, and that continually moves as we go through time. That is known as the terminator of the moon. So if you were standing on the terminator of the moon, you would see the sun just rising over one of your horizons. Now, one other thing that I want to point out here is that the moon looks like it's upside down and backwards. And in this case, it is, because a telescope will often flip the image either upside down, backwards, or a combination of the two. And so that's what we're seeing here. So if you happen to have a telescope and you look in it and you see that things don't look quite like the way they look in the sky, your telescope is not broken. It's actually functioning perfectly. So now what we're going to do is move our view just a little bit. So since everything is upside down and backwards, we look like we're going towards the south pole of the moon, but in reality we're moving up towards the north pole. And you see I'm highlighting two craters here. These are the craters Hercules and Atlas. And in just a few moments we're going to switch over and take a look at these guys, just a higher magnification. One thing to keep in mind is that the view that we have here is not taken through an enormous telescope. The Kingsport telescope, which we'll be looking through in just a little bit, is a 24-inch reflecting telescope. However, the view that we have here is from a 6-inch refractor that's mounted on the side of it, and it's basically used to help us find objects. It's got a much lower magnification, and it's not nearly as large as the main telescope. So to be able to see a lot of these craters on the moon only requires something like a small backyard telescope. Even a good pair of binoculars, especially if it happens to be a pair that is mounted to a tripod, will be able to point out or be able to show you a lot of the different features that you're seeing here in this video. So now I've frozen the screen and I am switching over to the main telescope. And so what we're going to be looking at is a more magnified view of those two prominent craters we mentioned earlier. Alright, so now we have the much more magnified view of the moon. Now we can see some of the smaller craters that are surrounding some of the larger ones. We can see more detail on the terminator of the moon, and we can see shadows coming from a lot of these different features. So now we're going to focus more on the two craters that I just highlighted. And we'd mentioned those earlier. They're called Hercules and Atlas. And a lot of questions we often get about the moon are just how big are some of these craters. They can look deceptively small in a telescope, but it will surprise you that these are pretty large. So for example, this crater that we're highlighting now, that's Hercules. It is about 69 kilometers, or about 43 miles wide. Now the crater to its left, which is actually to the right on the real moon, that is Atlas, and it is about 87 kilometers wide, or about 54 miles wide. This crater is also about 1.2 miles deep. So, compare that to, say, one of the mountains on the Earth. The height of that crater wall is comparable to a decent-sized mountain here on the Earth. Obviously, it's not quite as tall as, say, Everest, but still, that's a pretty good height for a crater wall. So the moon is about 2,200 miles wide from one side of to the other. So if we were to put that in front of the United States and put one edge of the moon, say, up at New York, then the other part of the moon, or the other side of the moon, would be around Utah. With today being July 24th, 2020, this is actually the 51st anniversary of the splashdown of Apollo 11. So last year, on July 20th, 2019, we celebrated the 50th anniversary of the first human landing on the moon. Now, we can't see that particular landing area on the moon right now, but in our field of view, in shadow, as I'm highlighting with my mouse here, this area is known as the Taurus-Littrow Valley, and this is where Apollo 17 landed back in December of 1972, which would have been our last manned mission to the moon. Now, we often get questions about whether or not we can see the flag on the moon. There are 6 flags that are planted on the moon's near side. However, because the moon is so far away, even the largest telescope on the Earth is not going to be able to show those flags. However, probes that have been in orbit around the moon have imaged the landing sites, and we can still see the remains of the different landers and some of the equipment that were left behind. So now I'm going to highlight another region here. So this region I'm circling with my mouse is a very, very smooth region as compared to this other region down below. So the region where my mouse is now is known as a mare. So that is a Latin term which means seas, because it was originally thought that these dark areas on the moon, which we can see with just our eyes, were large bodies of water on the moon. But we now know that those are actually very large impact craters that have been filled in with volcanic material. And because of their higher iron content, they appear a little darker. Those areas that are very heavily cratered are known as the highland regions. Highlands are, as their name implies, they are a little bit higher up in altitude or elevation than the Maria. But these are much more ancient regions. They've been around for longer, and so as stuff has continually impacted the moon over time, we see a record of those impacts from all the craters. The Maria are younger than the highlands. The craters that were there were erased when we had the large impacts come in, and then the impacts were filled in with volcanic material. We can determine the ages of objects in our solar system, or the surfaces of objects in our solar system, by how heavily cratered their surfaces are. So if we have a very young surface, like one of the Maria, then we see that the surface is very smooth. However, very ancient areas are very heavily cratered. So one of Jupiter's moons has a very, very smooth surface, which indicates that it is a very young surface.
Hi, this is Adam Thans from Bays Mountain Park and Planetarium. And what we're seeing right now is the original video of the live broadcast for our live viewing of the night sky with observers from all across the state of Tennessee. I work in Kingsport, Tennessee, at the far northeast corner of the state. And we're going to be showing you some interesting objects of the night sky. I will be doing Jupiter and Saturn. And you can see that we're just starting to show you Jupiter. Saturn will be later on in the broadcast. And I'll just mention very quickly that I am using a refractor telescope. That means that it uses a lens at the front end of the telescope. That's what gathers the light, and it's very good for planets. Now, I will say a few things. One, the video recording you're seeing here, the image of Jupiter is extremely overexposed on purpose. And that was to show the moons of Jupiter. Now, Jupiter has over 70 moons. Here we only see 4. It turns out these are the 4 largest moons of Jupiter, and they actually formed with the planet when it formed in our solar system. All the other moons of Jupiter are captured asteroids. They're much, much smaller, and some of them have strange orbits around the planet. Now, these 4 large ones, they formed with Jupiter, so they orbit the same way Jupiter rotates. They're also very large, on the order of like 4,000 miles wide, much bigger than our own moon. And so these are almost, you can consider worlds upon themselves. So very interesting to think about that. Jupiter, you can see, is just a big white ball there. You notice that it got smaller. Well, what's happening is that we are changing the exposure of the camera so that it can detect and display fainter the objects in the camera. So now you see that it's more of a proper exposure, but it's a lot lower, so you see the moons are practically non-visible. The planet Jupiter is a gas giant planet. It's the largest planet in our solar system. And if you look very carefully, you're going to see some bands going across the surface of Jupiter. Now, I want to stress, I keep mentioning surface of Jupiter. Well, there is no hard surface of Jupiter. What we're seeing is just the outer layers of the atmosphere of the planet, but the planet is a gas giant. So as you go down inside that atmosphere, well, the clouds just get thicker and thicker, and eventually it turns to a liquid. And then maybe way down in the center, there's maybe a rocky core about the size of our Earth. But essentially, it's just atmosphere. Now, those bands of clouds that you see, and I have to apologize, but it is the internet broadcast that is in our internet speed is kind of washing out the image, but those bands of clouds are the outer layers of the clouds that are stretched out because of the fast rotation of the planet. And so the planet rotates once every about almost 10 hours. There, do you see some kind of a orangey reddish color, a circular dot there, kind of center, a little bit right of center? That's the Great Red Spot. So the bands of clouds are from the fast rotation of the planet and stretching out the clouds. The clouds are different elements. So the whiter clouds are things like ammonia, and the darker clouds are other elements that, quite honestly, I'm not sure which ones. But that red spot is actually a storm system that is similar to a hurricane on Earth that we find on Earth. And it is so old that it was visible. It was definitely viewed about 50 years after Galileo, who was the first person to use a telescope on the night sky and see the planet Jupiter and the bands and the moons. But 50 years later, the spot was seen. Now, that was because of advancement in telescope quality, not by Galileo, it was by a different astronomer. But that storm may be millions of years old. We do not know how old it truly is, but we've been viewing it for about 400 years now. And so, again, right now it's about twice the diameter of the Earth. Think about that. 2 Earths would fit across. It used to be about 3 times the width of the Earth. But lately, in the last 5, 6 to 10 years, the Great Red Spot has been shrinking. So we're actually seeing a change in this feature that has been seen for centuries. So Lots of really cool things to see. I'm going to be popping up here in just a second. And there I am. And so I was just describing very quickly about getting out there in the night sky. So right now, Jupiter is visible in our evening skies. It's rising in the southeastern sky after sunset, and it's the brightest object that you'll see there. And then just below and to the left right now, you're going to see Saturn. So do try to look for all of that. And it looks like we're going to be going to the next person.
Hi, my name is Dr. Mary Kidd, and I'm joined here with Dr. Steve Robinson. We both teach physics and astronomy at Tennessee Tech University in Cookeville, Tennessee. And over the course of this event, we're going to show you a couple of nebulae.
So we here at Cookeville do not have an observatory yet, although it's something we're working on. So the equipment we're going to be using is set up in a backyard, my backyard actually. And just to tell you what it is that we'll be using, we have a permanent mount here with a fixture to put several different telescopes on here. They would have to be small ones, not big ones. The telescope we're using this evening is a William Optics 4-inch refracting telescope, meaning it's got a lens in it rather than a mirror. And there's a small guide telescope on top of that. And then on the back of the telescope is a Canon DSLR camera. And this is a camera, well, pretty much like you might have at home, except it has a couple of modifications to it. The first modification is that most DSLR cameras have a little filter inside them to stop infrared light coming into the camera, and that's been taken out of this camera so it can see to the very red end of the visual light spectrum, because that's important for astronomy. And the other thing, modification that's been done, is that it has a light pollution filter in it. Because we're in the outskirts of the town of Cookeville here, there is a lot of light pollution, and this filter just blocks some of that light pollution out. And then of course we have a cover for it, that protects it from the weather when we have bad weather. Now I'm going to hand it over to Mary to tell you about the first object that we're going to be looking at this evening.
If you look to the east in the summer, then pretty high in the sky, you'll see a trio of bright stars. Each one is from a different constellation. And because it's visible in the early evening in the summer, it's called the summer triangle. The first object we're going to be looking at this evening is located in the upper part of the triangle, closer to the star Vega, and it's called the Ring Nebula. So now we will hand it over to Steve so that you can see what we're getting from our telescope.
So here you see what we're getting through the telescope. This is not quite live, unlike the views that you've seen from our first two presenters, because what we're looking at here is what we might call a deep sky object. That's something that's a lot further away than planets or comets or anything like that, and is very faint, and so you would not see this with the naked eye. That's why we have a camera on the end of the telescope. If we were to just look through the telescope with our naked eye, we might be able to see this object, but not very well. So what we do instead is we put the camera on the end and we take a long exposure. And in this case, this is a 30-second exposure that we took a few minutes ago. You'll notice the background to this is quite blue. That's the effect of that light pollution filter that I mentioned before. You can see lots of stars in the background because it's a 30-second exposure. We're seeing a lot more stars than we would see with the naked eye. But you'll notice right in the middle here is a strange thing that doesn't look like a star, or maybe looks like a very big fat star. And if we blow that up, then we see that this thing is the Ring Nebula. It looks pretty strange, certainly doesn't look like any of the other stars in that view. You can see why it's called the Ring Nebula. It has this structure that has some different colors in it. You'll also see a blotchy background. What we can do is we can adjust the color balance of the camera here so we get a better view of this thing. So here we go to do that. And there we see a better color representation of the ring nebula. You can see it has a greenish blue center, then there's a kind of yellow patch around that, and then a red ring right around the outside. It's also not very well defined, unfortunately, and that's because we're only using a single 30-second exposure. If we want to get a much better picture of an object like this, then what we have to do is take many such exposures. And I'm going to show you now what happens when we do that. So here's a 1-minute exposure on the bottom left here. And you can see it's still quite fuzzy, and we have this mottled background that you can see. If we just take 3 of those exposures, 1-minute exposures, and average them out, then we average out a lot of this noise in the background here, and it looks a lot better, and we're beginning to make out some more detail here. And then if we go to the top right here, this is 50 1-minute exposures that were taken on a different evening, and you can see a lot more detail, including what looks like a small star right at the middle of the ring nebula. We can also make out the stars around the ring nebula in much more detail. So taking lots of exposures and averaging them together is what gives us much better pictures. So here we have, this is probably about 2 hours of exposure of the ring nebula, also known as Messier 57. We should mention Messier was a French astronomer who loved to search for comets. Unfortunately, he also saw some other things, and his telescopes weren't as good as the ones we have today. So he saw lots of fuzzy things in the sky that kept fooling him that they were comets. And so what he did was made a catalogue of those just so he simply wouldn't get fooled by them again and again and again. So the Messier catalogue, it's got over 100 objects in it, is really a list of fuzzy things that aren't comets. And this is Messier 57, the 57th one on his list, but you see the structure of the ring nebula there. And here's a picture done again with multiple exposures taken with a different telescope. And again, you see the structure of the rings with what looks like a small star right in the middle. And this is an example of what's called a planetary nebula. And what I'm going to do is hand it back to Mary now, who's going to tell you a little bit about what a planetary nebula actually is.
Well, let me first tell you what a nebula is. A nebula is a cloud of gas and dust in space. And there's several different types. You can see about 5 different examples here: reflection nebulas, dark nebulas, supernova remnants, emission nebulas, and planetary nebulas. This, as was already said, is an example of a planetary nebula. A planetary nebula is not what you might expect the result of a Death Star encounter, so you don't have to worry about that. What it is, it's actually nothing to do with planets at all. Early astronomers looked through, looking through the early version of telescopes, saw these round objects and thought they looked like planets, and so they gave them the name planetary nebula. But they're actually nothing to do with planets at all. What's actually going on is a star that's similar in size to our own sun begins to burn up all of its fuel. And when this starts to happen, the outer layers actually start drifting away, which you can see here in this planetary nebula. And this exposes the hot interior core of the star. Now, this, even though the fuel is burned up, this object is still extremely hot. And this heat actually energizes these gassy outer layers, much in the way that a neon light works here on Earth, and it makes them glow. Now, because this happens to stars similar in size to our own sun, when we look at nebulae like this, we actually are looking at the far, far, far distant future of our own sun, something like 5 billion years in the future, so there's no need to worry about that. That's everything about the Ring Nebula that we have to show you. And so now we're going to pass you on to our next presenter. And when we come back around, we'll have another nebula to let you see.
Hey everybody, John Kramer here. I am an amateur astronomer down here in Christiana, just right outside of Murfreesboro. Very humbled to go ahead and be part of this. I'm also representing the Bernard Seaford Astronomical Society, and very, very happy to go ahead and be broadcasting here with you with some of the modest equipment that I have. Is everybody picking me up okay? Super. All right, so tonight I am going to be showing you, and unfortunately it's not going to be live because of the weather, but I usually do a lot of live broadcasts, and I'll be showing you an image that I took about last month of this very cool object called a globular cluster. Now, this is not a candy made by Hershey chocolate. This is, reason they call it a globular cluster is because it is a glob of stars. And there are lots of stars in this particular object. We're talking up to 100,000, even some globular clusters out there have upwards of 1 million stars in this one cluster, and they're all kind of held together by their mutual gravity. So let's take a look at the object that I picked for tonight, which is one of my favorite globular clusters in the entire night sky. It's called Messier 22. And I'll give you a little bit of background real quick on what Messier 22 means. Now, this is Messier 22. This name of this object, Messier 22, he was an amateur astronomer back in the 1500s that was really into hunting down comets. Very popular thing to do back in those days. And he didn't want to go ahead and get confused about objects that he already knew of where they were in the night sky. So he started to compile this list. This happens to be number 22 added to that list. And that's why amateur astronomers, even to this day, call this Messier 22. Now, this globular cluster, of course, what you're seeing here is the globular cluster itself. And it's easy for you to actually see in the night sky too. And we're going to be transitioning here to where you can go ahead and see Messier 22 for yourself. But let's first talk about some cool and interesting facts about M22 in particular. So it was one of the first globular clusters that were ever discovered. As I said, it was originally actually discovered by a gentleman in 1665, and then Charles Messier added it to his list in about 1764. Now, astronomers use this unit of measurement called magnitude that is simply used to go ahead and give a value to how bright a star appears or an object appears. Now, as far as objects go, globular cluster M22 is a magnitude 5.5. But what does that really mean to you and me? Well, it's very bright. In fact, it's one of the 3 brightest globular clusters in the entire night sky. It's the 3rd one in particular. If you, in fact, were going outside in a dark enough sky, you'd be able to pick this globular cluster up visually without even having an optical aid. So that's pretty cool. Now, as far as its distance goes, it's not too far in astronomical terms here. We're talking about 10,500 light years away. So in essence, what you're seeing is light that has been traveling for over 10,500 years to get there. Now, the other cool thing about globular clusters are they are some of the oldest objects in the universe. Now, the universe they estimate to be about 13.8 billion years old. Messier 22, it's approximate age of, I think, 12 billion years old. So very, very old objects. Now, as we talk about globular clusters and how many stars are in them, they estimate that within Messier 22 here, it's approximately 83,000 stars. So what you're seeing here is 83,000 stars. We're of course not resolving all those stars, but still pretty cool to go ahead and be able to pick up. So speaking of pick up, why don't we go ahead and see where you can go ahead and look in the night sky so that you can spot this particular object. So we're going over to our planetarium program right now. It's called Stellarium. I highly recommend you check it out because it's free and it's wonderful. So now imagine that you are facing due south and you're looking up about a couple of fists lengths out. So if you hold your fist out right at the edge of the horizon, okay, and you go up to about where your tip of your thumb is, that's about 10 degrees. So if you put another fist on top of that, maybe just another half or so, you're going to get into this region of the night sky where we're looking. And the constellation that we're looking at is called Sagittarius. And it's one of the coolest constellations because it actually looks like a teapot. So you can clearly see the stars outlining the handle there going up to the spout. And then, of course, the lid. And one of the focus points here to find M22 yourself is to look for this star right here, the star at the top of the knob, if you will, of the teapot. And that star is called Caus Borealis. Now, if you were to take even a pair of binoculars, but like I said, if you looked and found this star and you look slightly to the left, which is the east, slightly northeast there, you too would be able to spot M22 if your skies were dark enough and you had really good eyesight. But let's say you didn't. Let's say you had a pair of binoculars. Well, you could spot M22 even with a pair of binoculars, as long as you point the binoculars in the general direction of Caus Borealis. You're going to see M22 in the same field of view. Okay, just nudge yourself over just a little bit over to the northeast, and you'll be able to spot M22 yourself. Now, another interesting fact about the area that we're viewing this beautiful object in is the fact that you're looking towards the center of our galaxy. You're looking towards what's called the Milky Way galaxy. So if you look, you're going to see a bit of a haze coming up from the horizon here, and especially right around that teapot of Sagittarius. That is our galaxy. You're looking towards the center, and all of these different objects that you see here that are highlighted on our planetarium program, they represent different objects. Some of these may even be covered by other astronomers here tonight. We've already checked out Jupiter there on the left. I think that was shared by Adam just a moment ago. And so that should give you a good starting point to where to look for Messier 22. So that is our At the Eyepiece object of the night from me right here, broadcasting from Christiana, Tennessee. We'll get you on over to the next person up on the Tennessee Virtual Star Party.
All right, I believe the next person is me again. So thank you, Steve. So now we're going to go back into looking at solar system object. I've moved the telescope, the Seaford telescope. So one thing about our telescope, it is a 24-inch reflecting telescope. It's been here since 1953, and we use it at pretty much all of our public events. So hopefully, again, one day you guys will get to come down and check it out. So the object we're going to focus on now is the Comet NEOWISE.
So unless you've been living under a rock, you've probably come across this comet quite a bit on social media. So I'm going to switch over to a live view from the camera again. So I'm going to, let's see, let me share my screen here. Give me 1 second to do this. And actually, I'm going to have to turn out the light so that we don't mess up the image. Hold on 1 second. All right, so I've got our red lights on so that I can kind of see where I'm going. And all right, so you guys should be seeing Comet NEOWISE now. This is just a 1 second exposure, but so you're not going to see the really dramatic image that you've been seeing all over the internet. But still, we can point out a few things here. You may have seen that when, just a few minutes ago, everything kind of looked red. That was still the red glow from the lights here in the dome. And so I've turned those off. And now we're getting a pretty good view from Brentwood here. We're looking over to the northwest. And in a moment, I'll tell you more about where to find this comet. So this comet is kind of fading from naked eye visibility. So unless you are in a really, really dark location, you're likely not going to be able to see this with just your eye. But a pair of binoculars, a small telescope, that will definitely help. I would go with a pair of binoculars since you can get a much wider field of view and you'll be able to see a little bit better view of it, especially against the background of stars. So in the center here, we see a brighter spot. This is what we would call the coma of the comet. Now buried down within that coma is what we call the nucleus. And that is the actual body that is going through the solar system and is creating this beautiful display. So that body is actually only about 3 miles wide, which is somewhat on the larger end of the comet scale. But you think about an object that's only 3 miles wide, you could walk around that in no time. But this is basically what astronomers like to kind of consider a dirty snowball that's in orbit around the sun. As comets come into our inner solar system, once they get about where Jupiter is, there's enough sunlight striking them that they will start to vaporize. And the term that we use is sublimate. So these comets have a lot of ices, and as sunlight hits those ices in the vacuum of space, instead of going from a solid to a liquid to a gas like we would normally think of for how ice vaporizes, in space, because there's no air pressure, the ices go straight from a solid to a gas. And as they do that, they release dust and rock. And so that's really what we're seeing. So on this scale, it looks like that bright spot in there is our nucleus. But in fact, from our distance, which is about 60 million miles from this comet, you wouldn't even be able to make that out. So it's smaller than a pixel on the screen there. Now, I'm going to switch over in just a moment and point out some other features. One thing that if you kind of squint your eyes just right, you'll notice that there is a tail extending down this way, which is backwards of what you see in a lot of images because the view through our telescope is upside down and backwards. So in reality, the tail is basically almost straight up and down. Okay, so if you go out with a pair of binoculars and find this comet, you'll notice that the tail is basically sticking up in the sky. Now I'm going to stop my screen share here. I'm going to pause it. I'm going to switch over and just show you a couple of other images, and we'll finish up with our comet and then move on to our next object. So 1 second here. All right. So now you should be able to see a really nice view of the comet. So this was taken out west. This is a little bit longer exposure. They had better sky conditions out there, and now you can really see that beautiful tail. So comets, they have two tails. We'll talk about what those are in just a moment. This comet is called NEOWISE because it was discovered by an orbiting satellite called the Near Earth Object Wide Field Infrared Survey Explorer. So it's a mouthful of a name there, but this mission is to basically discover and study a lot of these near-Earth objects, or these objects that come into our inner solar system. So that could be comets, as in this case, or it could be asteroids. This was discovered this year, and as it was coming into the inner solar system, and it rounded the sun on July 3rd. Some folks were worried if it would survive the close approach to the sun, but it did. And so after July 3rd, it was heading on back out into the solar system. Turns out we were actually kind of heading towards it. We weren't going to intercept it, but we were going to get a little bit closer to it over the coming weeks. So actually yesterday was our closest approach to this. The sun, even after July 3rd, as it was starting to get farther away from the sun, it was starting to fade because it's getting farther and farther away from that. Now, one thing that kind of helped us is that we were coming towards it somewhat. So that helped to keep its brightness up a little bit for us so that we could still view it. But now we've passed it, so it's getting farther away from us, getting farther away from the sun, so it's going to continue to dim. So if you have a good pair of binoculars, you'll probably be able to see it over the next week or two, maybe 3. If you have a good digital camera, it should be able to pick it up as well for a couple of weeks. But this is a long period comet. Comets like Halley's Comet, one of the most famous comets, those are short period comets. Halley's comes in every 76 years. So if you're generally about 200 years or less in the time it takes to orbit the sun, then you're considered a short period comet. But this guy, based on its current orbit, will not return to our inner solar system for about 6,800 years. So make sure that you catch it. I just want to show this video right quick. This is a really nice time lapse from the International Space Station. You'll see the constellation Taurus rising over here on the right. In fact, right there is the Pleiades cluster, which we can see in the fall and winter. And over here is the constellation Auriga. And that bright star right there is, oh, I'm sorry, did I just notice that my screen sharing is paused? Can anybody else confirm that? Okay, so what were you guys still seeing? The comet in the telescope? Oh darn, I'm sorry guys. Let's resume the share. Okay, so what I was pointing to earlier is this view here and then this view. So you didn't really lose much. So what I was talking about still applies. So I apologize for that. But now what I want to show you is a really nice view from the International Space Station. It's a nice time lapse. And again, over here, this is the constellation Taurus, and over here is the constellation Auriga with Capella as that really bright star, one of the brightest stars in our sky. So it's a fast time lapse, but it's a really nice view. And if you watch over as the sun is coming up over the horizon, there's our comet. So the folks on the space station got a really nice view of it. Just one or two other things here. So here is more of a view of those two tails. So this dust tail, this is really what we're seeing. And long exposure photographs will pick out this ion tail, which is, these are basically molecules that are interacting with particles streaming off the sun, and they start to fluoresce just a little bit. But they are pushed directly away from the sun. So this tail always points directly away from the sun. And our dust tail, it tries to point directly away from the sun, but those dust particles, they have a hard time being pushed by sunlight and those particles streaming from our sun, what we call the solar wind. So they get pushed somewhat away as the comet is moving, so we get kind of this curved dust tail. Okay, but the dust tail is really what you see by eye. And then finally, if you don't know where to look, thankfully our comet is coming up through Ursa Major. So this was yesterday evening. Right now, it's about right here. So it's still under the Big Dipper that we see right through here. So you can use that kind of as a guide and use these, bright stars here as a little bit of a guide and just kind of head up towards the constellation. It's called Comet Berenices. So, and as the comet is moving on out, from our perspective, we'll see that tail appear to change orientation just a little bit, because remember, it's trying to point away from the sun. So as we're all moving around the sun, our perspective is changing, and that the angle that that tail will appear to point is going to change. So next good clear night, actually tonight's still a good night. It's still decently high up, probably the next hour or so. Go out, try to find it. With that, I will turn it back over to our next presenter, which I believe is all the way over in Memphis.
Thank you very much. I'm Jeremy Veldman with the Memphis Astronomical Society.
Hey, hang on
and
just
I've
a
got-
second. Before we move to the next person, we had a question for Dr. Teets. Somebody wanted to know, how powerful is the telescope?
So that's a good question. Hold on one second. Turn on some lights there. So the telescope, its main mirror, its light gathering capacity, it's a 24-inch wide mirror. So it can gather about 10,000 times as much light as the human eye. Now for the view of the comet, because this telescope has such a narrow field of view, we weren't actually looking through the main telescope this time. We were looking, let me see if I can show you. There is a telescope on top of it. It's a little one. I'm sorry, I'm trying to get the view turned here. So if you can see that smaller tube on top, that is the one we were actually looking through. So that's our finder scope, but it has a much wider field of view. And that one is about 6 inches in diameter. Okay. All right, and I think we're off to our next presenter in Memphis.
I'm saving up to buy a telescope like Billy's one day. I'm Jeremy Veldman with the Memphis Astronomical Society, and I've got something to share that a couple of our members have done recently. I'm going to go ahead and share my screen here. And I'm going to find a video here. Let me see here.
All right, we are the Memphis Astronomical Society, and we are heading up the caboose for this Tennessee virtual star party. And we got a couple things to share with you. Again, the weather here has not been the best. The skies have not been very clear in the last week or so. But I want to share with you a couple of things that have happened recently. This is pre-recorded, but hopefully give you an idea of what some of our members have done. So this is an image of the sun setting at the Wilderness Rider Buffalo Ranch and Adventure Park in Arkansas. It's about 5 hours from Memphis. And one of our members went to view Comet NEOWISE from this spot. Now the skies were a little iffy, but he did take some pretty spectacular shots of the comet, which has of course dominated the headlines recently. I love this picture because you can see both the dust tail and the ion tail of this incredible comet. This is the best comet I've seen in 25 years since Hale-Bopp. Here you can see it low on the northwestern horizon with some clouds that he battled when he took these images. Here's another great shot. Sun setting, comet out, again, low in the northwest sky. It's been rising every night since. It's starting to dim now as it fades away, but about a week ago was really a great time. A little less than a week ago was a great time to see this comet. So these are some shots from last weekend at this spot in Arkansas, the Wilderness Buffalo Rider Ranch State Park, for lack of the better way to say it. Again, this is another great shot of the comet. You can see the coma, you can see the dust tail, you can see the ion tail a little bit. Just a lot of details in this comet. Seeing a lot of pictures of this on social media and on Facebook, as well as YouTube. A lot of people have taken some really cool shots of this comet. So just sharing some of the images that one of our members, Brian Hancock, took when he was in Arkansas. Here's another one. You can see clouds coming in. So weather has been, certainly was unpredictable when he took these shots. This is another great shot. Again, you got the clouds, you got the sky, you got the sunset, and you got the comet. Just a really great spot. Now, the second part that I want to share with you is just kind of a brief presentation on astrophotography. Now, the person that put this together, I asked him, he's one of our newest members, Merrill Miller. Now, he may be new to the Memphis Astronomical Society, but he is one of our most advanced astrophotographers. He's been doing it for years. He is actually a graduate of the University of Kansas in electrical engineering. He worked at Procter & Gamble for years, and he was responsible for the production of Folgers, Coffee, Zest, Dawn, Tide, and he also did some time here in Memphis as the plant manager of the Buckeye Cellulose on Jackson Avenue. He retired after 31 years, and his final assignment was the plant manager in Jackson, Tennessee, producing most of the world's Pringles. So if you like Pringles, they're one of my favorite snacks. Merrill Miller, the person who put this presentation together, whose hobby is astrophotographer, what he did professionally was produce most of the world's Pringles. Pretty cool stuff. Here you can see his sky shed. I constructed this a few months after I built my home in 2011. During the home building construction, I had the concrete pad and 8-inch steel piers placed. Additionally, I installed power and 4 Ethernet cables to my home LAN system. The roll-off roof utilizes an inverted garage door opener to open and close the roof, all controlled from my home office. And here you can actually see a shot of his sky shed in the backyard from his bed. My quote-unquote photo gathering place, where I spend most of the night during an imaging session. Since it's now fully automated, I just get up in the morning, gather the images, check them for quality, and then store them in my current work folder until I have enough to do a decent job for the final image. So he has completely automated the process of taking a deep sky image. It's not like you just go out and take a shot a minute. I mean, deep sky astrophotography is very involved because the objects are so dim that you have to take several long exposures to gather enough light and then process the image. So it literally is an all-night affair. And most people stay up. Most astrophotographers stay up all night monitoring their equipment. Merrill has it completely automated, and he can sleep while his shed and the software does all the work. Pretty cool. I get excited when I see the possibility of clear skies for the upcoming evening. I check the astronomy weather forecasting on the internet. In this instance, I used Clear Outside, a link available on the Memphis Astronomical Society website. I look for all green and minimal moonlight. So you can see on this date, Saturday the 18th, waning crescent, which is a great phase for the moon. Skies were clear around midnight, very little cloud cover or precipitation. So this was a good night to observe. Once I determine that the weather is good, I use Telescopius to choose my target. I set the parameters of my location and equipment specifications to allow me to choose one that fits my needs. Telescopius is a great planning tool and is free to use. So in this particular case, he chose M13, which is the Great Globular Cluster in the constellation Hercules. This is a great target. This is actually one of the Messier catalog has 110 deep sky objects. And I won't go through them, but once you get past the moon, Jupiter, Saturn, the bright planets, and you want to graduate to more challenging targets, the Messier catalog is kind of the next natural step in your evolution as a backyard amateur astronomer and astrophotographer. This is a great target. M13 is pretty easy to find with your telescope, and it's never disappointing. Globulars just kind of burst into your eyepiece like a firework, and they're just kind of like puffballs of stars. It's a great target. You can see here the details of these stars coming out. Now, a little history here. Globular clusters are what Harlow Shapley studied to determine that the sun is not at the center of the Milky Way galaxy, as it was thought to be for hundreds of years. Turns out that Harlow Shapley figured out that the distribution of globular clusters was around the center of the galaxy and the sun was off-center. Here you can see an image from the Kepler K2 mission of M3, another globular cluster, And globular clusters have an abundance of what's called R.R. Lyrae type stars. These are really old red giant stars that pulsate in regular intervals, and it makes it possible for you to measure the distance to those globulars. So that was Harlow Shapley's work. And he figured out that the globulars are distributed in the halo of our galaxy around the galactic bulge. So our understanding of our place in the Milky Way came from his work. Here you can see the sun in the disk of our galaxy about 25,000 light years from the center, and then the globulars are up here in the halo. So that's essentially, that's the importance in the world of astronomy for globular clusters. And here you can see again, another great target, another shot of a globular cluster. They don't disappoint when you look at them in the eyepiece. Okay. Operating the power controller. Next, I activate my power controller, which in turn activates, as needed, the roof, opening, closing, the video camera that I have in the sky shed, and the telescope equipment. And here you can see the roof rolling off. I can fully automate the startup of the equipment, but if I'm home, I usually manually open the roof. There have been times I've been out of town and set up the automation to start the opening/startup sequence. This is after I have done the necessary choice of guiding, operation, and focus stars, which frequently takes a lot of time and patience in the first night of a new target. Here's the software that he uses. Next, I load all of the necessary software: Maxim DL, Focus Max, MaxPoint, and CCD Commander. CCD Commander is the overall software control that integrates the several pieces of software. It allows you to choose where you're going to point the telescope, which filter you use, how many exposures you'll take, what duration of exposure time, guiding, autofocusing, and the length of the imaging session. By using simple VB scripts, it controls the opening and closing of the roof. So these are the programs that Merrill Miller uses to control the entire astrophotography process, including the observatory. Point to initial target for focusing. Here you can see the telescope actually moving into position. It's necessary to sync the telescope to the stars in the night sky to ensure accurate point and control. It takes 2 steps. The first is to do an initial focus on one of the stars that the telescope sees. And here you can see it actually moving to M13, which this time of the year is almost straight up. It's in the constellation Hercules in the Keystone. Perform initial focus. The focus routine is controlled by Focus Max, which provides a very precise focus. Given the metal in the telescope and equipment changes as the night cools, I have a temperature compensating focuser. But for really precise focus, I have CCD Commander stop imaging and focus once per hour. The result is very tight stars. The initial focus is necessary for the startup step. And Focus Max controls the temperature compensating focuser also. The next step is to take a 20-second image to get the precise location of where the telescope is pointing. This image is then compared to a database of stars, and once a match is found, the system is then synchronized to this position. The process of campaign stars to a database is called plate solving. This allows the telescope to be precisely pointed to the desired targets throughout the imaging session. So this performs initial plate solve to determine the exact pointing position. And then you start imaging with a telescope. So now the imaging processing process starts. Now you need to keep an eye on the weather. Although this evening was forecast to be clear, I was having some difficulty with keeping the guiding of the telescope in the precise position. So I checked the satellite view above my location. Sure enough, there were some clouds beginning to encroach on my location. Fortunately, they moved out within an hour, so I didn't lose too much imaging time. And here you can see a snapshot of his control station. This is his office in his house that controls the observatory in the backyard. My office computer is actually just an interface for the actual telescope computer that does the work. I use TeamViewer to access via my LAN this computer that's located in the utility area of my home. This computer is then connected by both the Ethernet cables that I installed and a long-distance USB setup. It was a heck of a lot of fun designing, experimenting, and building the total package. This is what engineers do. They tinker, they build, and then they create really cool stuff. So when you combine engineering, curiosity, perseverance, and astronomy, you create a monster, a really cool monster. So here you can see a snapshot of one of the 5-minute exposures of M13, this globular cluster target. This is the first 5-minute exposure of my target M13. CCD Commander will continue to take images and do autofocusing until the time I specified to shut down. So you need many of these exposures. Again, deep sky objects for astrophotography are very faint. So you got to take several images and then stack them later. So you will need many of these exposures to bring out detail and color. So this is one 5-minute exposure. He's going to take dozens of them, dozens of 5-minute exposures throughout the night of this target, M13, and then stack them and process them later. So when it's over, CCD Commander completes its session. In this particular case, it was programmed to be completed at 4 a.m. So at 4 a.m., the software program, CCD Commander, commands the telescope to park, go back into position, and then close the door. So similar to when you go home and you park your car in your garage, and then you walk up and you hit the button on the side of the door, and it closes the garage door. Same type of process here. The software program does that for him. He's probably asleep by now, or he's out of town, but it closes the roof of the sky shed automatically, just like you would close the garage door on your house. And then comes the processing. After several nights of imaging a target, the captured images are stacked and processed into a final image. I process the images into final form. Generally, a faint object requires a minimum of 30 plus hours of exposure to bring out the proper detail. M13 is bright and requires less exposure time. This image is one I completed a few years back with a smaller telescope, but it is a beautiful heavenly body. The processing generally takes a couple of days of off and on work with PixInsight. That's the program that he uses to stack and process images. It took a number of years and a lot of experimenting with various equipment and software to be successful at automating the process. I started with a 10-inch Meade Schmidt Cassegrain telescope on a tripod and worked from there. There were a lot of sleep-deprived nights in the first few years of learning, but this is how you become. Astrophotography is kind of a combination of science and art. It really just requires a tremendous amount of perseverance, patience, tinkering, experimenting, and endless tweaking. It really is like an artist painting a picture in some instances, where it just there's a certain eye and a certain there's an art to it. I guess that's just the best way to put it, to being a skilled astrophotographer. So that's it. Here's the equipment he used. Again, I'm no expert, so I would in no way be able to answer questions on the details of these. But you can see he used a 14-inch Meade telescope. He used, this is the equipment he used for the camera, the filter wheel, the adaptive optics, focuser, the digital loggers, Ethernet power control, and then the software programs that he used. Maxim DL for imaging and guiding, MaxPoint for as a pointing aid, and then also CCD Commander, which is your overall program that controls everything. So again, we're the Memphis Astronomical Society. We're a nonprofit public service organization promoting interest in education and astronomy and related sciences. Our website is memphisastro.org. We're on social media, Facebook. We do have a YouTube channel at Memphis Astron Society, where we've been broadcasting our monthly meetings. That's my shameless marketing plug. If you're interested in learning more, you can join our list at joinmas.com. Thank you very much. Really enjoyed this event, especially the objects that the other presenters earlier in the program presented. Thought it was a great opportunity to see and learn and do it virtually. Hope everybody is staying healthy and safe, and maybe we can do this again. For Jeremy Veldman, president of the Memphis Astronomical Society, thanks again.
Okay, are you with me? Has this been an amazing journey so far? Guys, we've been to Kingsport, we've been to Nashville's Dyer Observatory, we've been to Christiana, just south of Murfreesboro, we've been all the way to Memphis, we've been in Cookeville. I say we do it all over again. My friend Adam up at Bays Mountain Park and Planetarium in Kingsport is going to show us Saturn. I just double checked with him. This ain't a picture. This is the real deal. Are you ready to see Saturn? And I do have to say this just really quick. We have to say thank you to Friends of Warner Parks for sponsoring this Zoom meeting, which is allowing us to do this, to Metro Parks of Nashville for giving us the Wi-Fi and giving this amazing meeting space and taking care of me, and also Warner Park Nature Center. Not to mention all of our great presenters and Theo and Nathan Wellington here tonight in charge of tech. They've done an amazing job. Now, Adam, back to you.
All righty. Thank you, Heather. Well, yes, we have seen a number of really cool objects in our night sky. And so what I'm going to be doing is sharing my view of Saturn. All righty. Whoops. Okay. Just like what we did with Jupiter, this is extremely overexposed. You're going to see Saturn as a UFO. It looks like a UFO. It's an oval of light. It's so overexposed. But do you see the little dot to the kind of the upper right? All right. Do you see that little circle there? That little round dot? I'm trying to be real still by not even talking so it won't jiggle. Okay, that little dot right there is the largest moon of Saturn, called Titan. Now, Saturn has always been seen in the sky with the unaided eye. Again, Galileo Galilei, the Italian scientist who lived 400 and so years ago, first looked at it with a telescope and described Saturn as having ears. Well, obviously it doesn't, but it does have this weird shape. Why is it kind of oval shape? What's going on? I don't know if he actually saw any of the moons like Titan. I think that might have been discovered. I think it was discovered later. But Titan and Saturn were visited by a spacecraft a number of years ago called Cassini. And there was a probe that actually left the Cassini spacecraft to land on Titan. And there's actual footage of that happening. And you can find that on NASA's website. So I'm going to do two things here. This is very live. As you can see how it jiggles around. First, I'm going to center this. All right. And okay, right there. Just give it a little touch. And then I'm going to change the exposure so that, all right, you saw it get smaller. Don't worry. I'm changing the exposure. It's really just a setting through the camera. There we go. That probably is good. Now I'm going to, on the camera, kind of zoom in. And, all right, let me center it. All right, right there. Okay. So now we have lowered the exposure and we're looking at Saturn live. Look very carefully. First of all, you'll see the planet Saturn as a round disk. You'll also see the rings of Saturn go around. And you can see that they're tilted. So our point of view of Saturn is not edge on. We're not looking at the equator of Saturn. We're looking at, I believe if I'm guessing right, the southern polar region of Saturn. Look, you'll see two gaps, which is the space between the planet Saturn and the rings that go around it. And if you look at this image, this is why Galileo called it having ears, because it's got these two things sticking off to the side. Now think of his telescope. So we're doing a little history lesson. He made his own telescopes. He ground his own glass. And so the image was kind of poor. So he couldn't see any detail. Now right now we're getting through a little bit of some turbulence. And you can see that the image is getting a little darker. So let me just increase that exposure just a touch. Okay. All right. Look at the rings of Saturn. Look to the outer edge of the rings. And in moments of decent seeing, where when the image steadies, you're going to see these little black kind of thin lines. And that is the Cassini division, discovered by Cassini about 50 years after Saturn was first seen with the telescope. So that would have been about 1660. And so that thin line, that thin gap right there was thought to be, oh, there's nothing there. There's just a gap in the rings. Well, actually there is material there. It just doesn't have as much ice. The ice in the rings is what's reflecting the sunlight and allowing us to see the rings so well and so bright. So again, this is a live view. I'm going to try to keep real steady. And if you also notice that the planet Saturn had some banding on it. In fact, I need a lower. You notice how it got brighter? Well, we're dealing with the atmosphere here. So again, very live. And let me get it centered. Sorry, there we go. All right, you notice how the exposure was enough now. You can see the Cassini division better. And you can also kind of eke out a little bit of the banding on the planet Saturn, just like on Jupiter, with the bright and dark banding. And that too is also because Saturn rotates very quickly, almost as fast as Jupiter, but pretty close. And so it stretches out those outer layers of clouds. Saturn is called the gas giant planet. And excuse me. And it's part of the Jovian planets, the four planets that are those four planets that, if you go outwards from the sun, so you got Jupiter, and then Saturn, then Uranus, and Neptune. All four are called the Jovian planets. They're all very big, but Uranus and Neptune are nowhere near as large as Jupiter and Saturn. And so with that, and I realized I need to make a correction. I said about 100 Earths would fit in Jupiter. That's wrong. It's about 1,000 Earths would fit in Jupiter. About 850 would fit in Saturn. And so, but the rings of Saturn are larger than Jupiter. And here's one fun little fun fact. Saturn is has a density so low it would float in water. Think about a bathtub that big to hold Saturn. So here is Saturn. And while we kind of look at this for just a moment, I'll just mention about Bays Mountain Park and Planetarium. We're in Kingsport, Tennessee, in East Tennessee. We have 3,650 acres of a nature preserve. And almost all of it is just untouched woods and a large lake in the middle. And we have exhibits, animal exhibits. We have actual, inside exhibits in the Nature Center. We also have a very nice planetarium in there as well, which is where I work. And we do have an observatory. We do night observings as well. I'm going to unshare my screen, and I am going to give it back to Heather. Heather, do you want to have the... Well, probably not, because she's walking off. So I'm going to give it back to the next person.
Hey guys,
Okay.
we're getting ready to do something really fun now. We're going to jump all the way over to Memphis again. And we're going to check out, I got to check my list. We haven't had Cookville next? No, we haven't done the second Cookville. We haven't done the second Cookville next? Okay. Stop the presses. The woman that you got to see at the very beginning, Mary, is going to go again. And we're going to do Cookville again. And guys, you're going to love this. So be ready for Mary from the physics department at Tennessee Tech University.
All right, we're back in Cookville, and now earlier this evening, we showed you the ring nebula that you could see up at the top of the summer triangle. Now we're going to move over to the Dumbbell Nebula, so I'm going to switch you over to Dr. Robinson with his telescope looking at the Dumbbell Nebula. Ready?
So this is another one of those Messier or M objects. You had it heard earlier. This was really a list of fuzzy things that aren't comets, basically. Charles Messier was looking for comets and kept getting fooled by these other things, and so decided he would make a list of them so he could refer to it later on. But this is M27. It's called the Dumbbell Nebula. Let me blow that up a little bit. This is a 60-second exposure that we took just a few minutes ago. It's called the Dumbbell Nebula because when people first looked at it, they could only see the brighter parts of it through a telescope, and so they kind of saw a dumbbell shape, and so that's what they called it. But now that we have better resolution and better light sensitivity, we can see that it is really another circular type object, or spherical really, and it's another example of a planetary nebula that Mary explained what those were before. But this one doesn't look quite like the previous one, and in fact most planetary nebulae that we see in the sky look very different to each other, and astrophysicists aren't really sure why that is. It's probably just that the formation process of these things is so complicated that any slight deviation from one to another results in a different shape or a different pattern. One thing to point out here is, remember when we saw the ring nebula, there was a red ring around the outside, and you see some red light here. There was also some bluish green in both. The red light is really important in astronomy. It comes from the fact that gaseous hydrogen, which is in fact, all stars are mostly made of, when it gets excited, it glows with that pinkish red color. And it's a particular color red. It has a particular wavelength. And so what astronomers often do is they will put a filter in their telescope to just let that particular color of red through to study the hydrogen in an object. What you can also do is use that red light to enhance the color pictures that you take. And so over the past, a few weeks ago, we took a lot of pictures of the Dumbbell Nebula, straight color pictures, and also these what are called hydrogen alpha pictures, and then combined them to make one single picture that Mary's going to show you now. And then she's going to talk about something interesting that people don't realize about these planetary nebulae.
So here's the picture that Dr. Robinson was just mentioning, where we have the combined images where you can see that the red was taken with that special filter letting in the red light, and then combined with the other filtered light taken over a period of several days and weeks. What is kind of interesting about some of these objects, these deep space objects, is actually how large they are in the sky. The thing is that you can't see, for example, the Dumbbell Nebula with the naked eye, But if you could see it with the naked eye, it would actually be about half the size of the full moon. So that would be really cool if we could see it. And the ring nebula that we saw earlier tonight would only be about 1/10 of the size of the Dumbbell nebula. So it would be really nice if we had eyes that could actually collect enough light to see these objects with the naked eye, so that we would see a sky full of these bright, colorful blobs. And we don't get to see that, unfortunately. So that is the Dumbbell nebula. And I think now we go on to our next speaker.
Okay, we've got one more place to visit, and then I have a couple of questions for our astronomers from this evening. So this guy, I'm really excited for you to meet. You haven't met him yet. His name is Dave Manis. He's from Pink Palace Museum of Science and History in Memphis, Tennessee, and he's got a lot to share with us. I'm so excited to introduce him. I've been to that planetarium before, and I learned about knots. Not the kind of knots you think about, the kind of knots that sailors use. So I'm hoping that he's got a lot of good stuff to share with us. All right, Dave.
I didn't know where to unmute. Am I unmuted? Can you hear me? Am I on? Okay, I don't hear anything. Great. All right, we're live. Let's see if I can go to my program here. Can you see this? Someone will have to unmute and speak because I can't see your screen anymore. If this doesn't work, I've got some other things that I can do. But if you can see this, this is a different program, and it simulates what I do in the planetarium. And it's a program called Starry Night. And so I've got it set for now. We can see that the moon is over here. It's about to set. And I believe we're almost to the point.
Hey,
of
Dave.
using... Yes.
Hey, Dave.
Yes.
Hey, Dave, can you share your screen? Share your screen.
Oh, okay. There we go. Let's go to this to share. Ah, have you got it? All right, what I was saying was there's the moon about to set. What I typically do is guide people through the nighttime sky in the planetarium theater. And I'm gonna choose my constellation selector. Okay, there we go. And you, of course, have already been introduced to the Big Dipper here. That's about to go away, but I just wanted to point out that tonight, if you just go backwards, you know, you usually use these two stars to find the North Star by going up this way. Looks like today or tomorrow, if you go the other way, go past that star in the foot of the bear, the comet will be located right about there. And speaking of the bear, there she is. That's Ursa Major. And I love telling stories in the planetarium because that is the tradition of ancient astronomy. It was basically people sitting around campfires, enjoying a full meal and looking at the stars and connecting the dots. That's all they did. And people came along and said, oh, well, that kind of looks like something such and such. And other people kept on the conversation and they started building and adding to the stories. And it tells you a lot about ancient peoples and what they did. And I'm really a big fan of just looking up at the nighttime sky and enjoying what you can see in a nice clear night. Well, anyway, sometimes I tell a story about the bear, the big bear, and the little bear. The story is really kind of risque, the whole story. So I usually tell a short version of it. And that is basically these bears were getting into trouble. And Zeus, the king of the gods that they believed in, decided he was going to help them out. And to help them out, he thought they needed to be somewhere safe. And what better place but up there in the night sky? So he just grabbed hold of their tails, swung them around his head a few times, and tossed them up there where we see them today. And of course, that's how their tails got stretched out. Bears don't have long tails like this, do they? All right, and there's, once again, the bear cub, Ursa Minor. Now, Ursa, the name, has an ending with an A. If she were a male bear, it would be Ursus. But I guess because the little bear, he is male, since he's associated with his mom here. In this case, they call him Ursa Minor. So there we go. All right, I have to switch to my other hand in order to be able to move around the sky here. So let's go down this way. And if you follow the handle of the Big Dipper, there's a saying that you can arc to Arcturus. And that's this star right down here. I believe it's the fourth brightest star in the sky. Hard to miss. Got a slightly yellowish color to it. But up above, I like to point out something that looks like a nice summertime treat. And you see an ice cream cone here? Even a scoop of ice cream on the top. So that's how we want to connect the dots here. There's the ice cream cone shape. It's one of those waffle sugar cones. And off to the side here, looks like a scoop of ice cream that's fallen off of the cone. Well, anyway, the scoop of the ice cream cone is really supposed to be a farmer. And where is my other? There's a constellation selector. His name is Boötes. And Boötes was, well, his story is kind of a sad story. He was a farmer who grew the best grapes in the land. And these grapes were so good that he attracted the attention of Bacchus. If you know anything about Bacchus, he was kind of the party god. He arranged all the parties, and he decided to get the best grapes, so he bought them from Boötes. And in return, Boötes learned the process to make wine. And so, having been given the recipe for wine from Bacchus, he thought he'd invite all of his friends over to have this party and drink the wine that he made, his first batch of wine. Well, his friends loved it, and they kept drinking, and they drank more and more. And, well, you know, too much of a good thing is going to have some consequences. So his friends thought that he had poisoned them. They started to feel ill. And unfortunately for him, they decided that since he was poisoning all of his friends, was going to take over all of their farmlands, they decided to string him up. So they hung him on a tree, and that was the end of Boötes. But that wasn't the end of all of his friends. They woke up the next day, they had a headache, but they really felt sorry for what they had done, and they pleaded with the gods, prayed to the gods for forgiveness and something that they could do. Well, you know what? They did something for Boötes. They placed a picture of him up in the sky. And that picture reminds everyone to not jump to conclusions. So some of these stories in the stars have a moral to them. and that's one of my favorite. Now, right next to Boötes is Corona Borealis, and this one is also related to Bacchus because he attended a party on Earth, apparently, that was attended by a beautiful princess who was named Ariadne. And he tried to get closer to Ariadne. He wanted to attract her, and he boasted about himself. He said, well, I'm a god and I live up on Mount Olympus. Well, ladies, has that ever worked? Well, in this case, Bacchus decided, well, she doesn't believe me. I'm going to prove it. So he takes his laurel leaf off of his head, and laurel leaf crown that apparently was fashionable up on Mount Olympus, and he tossed it up into the sky, and it became this crown that you see right here. And so she, of course, believed him after that, and she joined him up on Mount Olympus, and I believe she became one of the minor gods up there, and had a great time. So that's one of the stories with a happy ending to it, and not all of them, like we learned with Boötes, have happy endings. Now, I am known to lose track of time, so I can just keep on going, but somebody signal me if I'm running over. Okay. I'm going to keep on going down toward the south. You may recognize some of these constellations down here. We've talked about them quite a bit already. Let's see if I can, oops, I've got to switch back to my constellation selector now. There's Scorpius the Scorpion. And we never really heard, I don't think, about how Scorpius got there in the sky. My version is different. Well, the storyteller always has the prerogative of making the story any way he wants. And that's how stories evolved over time. Well, Scorpius got up there basically because it was a response to a bragging giant. And this giant we can see in the winter sky, his name is Orion. Well, when he was alive, he was, and by the way, he was the son of Poseidon. He wanted to prove his prowess as a hunter, so he would go through all over the earth and bash all these creatures on the head with his club. And so Gaia, who was the goddess of the earth, who didn't really appreciate what he was doing, decided she would send this tiny creature to cut this giant down to size. And so Scorpius was sent to sting Orion on his foot. He crawled up and did so, and Orion keeled over. Unfortunately, he squashed the scorpion on the way down. So that's the end of Orion, but it's also the end of the scorpion. Well, Orion's friends, most of the other people up on Mount Olympus, decided to put an image of Orion up into the sky. And Gaia said, well, if you're going to do that, then I'm going to put a giant image of the scorpion up there as well, because after all, he was the giant killer that I sent to stop him from killing all of my creatures. So, well, okay, Zeus heard that. He said, I can't stop you from doing that, but I don't want to be reminded of how Orion died. So you can put him on one side of the sky and Orion goes on the other, and we'll never see him in the sky at the same time. And you know what? That is actually the case. So you'll never see Scorpius and Orion together. Maybe somewhere up in space, but on planet Earth, you'll never see them together. But he's up there, and maybe we need some protection now. There's this giant scorpion up there in the sky, and so who came along to help us out was Sagittarius, the archer. And when he made his way up into the sky, he was given the job of protecting us. So if this giant scorpion ever decides to climb out of the sky and terrorize the earth, we have Sagittarius ready with his bow and arrow to shoot the scorpion, it looks like he needs to aim a little bit higher because this star Antares is the heart of the scorpion. So if he wants to kill the scorpion efficiently, he needs to aim a little bit higher. There we go. All right, switching back to my other hand, my hand will come around and see more of the nighttime sky. I'm going to follow the Milky Way on up. We've already talked about the summer triangle, those objects right there. Here's another view of, oops, there we go, constellation selector, Lyra the Harp, the Eagle, or Aquila the Eagle, that's right. And then let's see what Cygnus looks like. There we go. All right, and I'm going to keep on going. Oops, I can't move it until I switch.
Okay.
Yes.
Are we still here? Is everybody still here? Because we're not done yet. The best is yet to come because we have questions from the audience.
Great.
And my first question is going to be for Tennessee Tech University in Cookeville. It's going to be for Dr. Steve. How powerful does a telescope need to be to see the Dumbbell or ring nebulas? So, Steve, can you take that?
Actually,
Yeah.
Actually, you don't need that powerful a telescope to see them with your eye. They're only just below what we would call naked eye magnitude, but you won't see all the details or the bright colors if you just look with your eye through a telescope or through binoculars. If you want to see all those details and the colors, then you really need to do some long exposure photography. The problem we have with human vision is it has no, what we would call persistence of vision. That means your eye doesn't remember what it's seeing from fraction of a second to the next fraction of a second, whereas a camera does, and so it's able to add up all that information. Whereas your eye and your brain can't do that. So you'll be able to see them, you just won't make out all the details and all the bright colors.
Thank you for sharing with us, Steve. Okay. I like this question. This is really good. And by the way, I have a pile. Next question is for Dr. Teets at Dyer Observatory with Vanderbilt University in Nashville. Why is the comet green?
So there are some different molecules that are found in comets that can contribute to that green color. For example, carbon monoxide and cyanogen. When they are in the vacuum of space and they interact with some of the high energy sunlight, that will cause those gases to fluoresce. And so different elements and different molecules have their own unique colors that they can, that they emit. And that's often, or that's really the way that astronomers figure out what something is made of, is by the colors that it emits or the colors that it's absorbing. So those are two of the main gases, cyanogen and carbon monoxide. Those are two of the main ones that really help with that green color, or that kind of bluish green color.
Okay, this question is for Base Mountain Park and Planetarium in Kingsport. Adam, you might have already covered this, but people have been going in and out. So how many moons does Saturn have like today? And how often are they finding new moons?
That's a good question. The number keeps changing. I haven't looked in a while, but I think I'm pretty sure it's over 70 moons. Anyone else in our group can say how many there are. I mean, I could probably just get online real quick, but Billy,
I think the last count that I heard was 72, and it was in the lead for a little while, and then found a whole bunch more around Jupiter, so it's up to 79 again. So he's back in the lead for today.
Okay, thank you. So there you go. Both were over 70, so I was right. But for even more accurate information, Yeah, when I was going to school, the numbers were a lot lower. They were in the teens and 20s for Jupiter and Saturn. So they just keep going up. But the moons they keep finding are just tinier and tinier. And I'll just take this real quick moment. Remember how Jupiter had the 4 largest moons, those Galilean satellites? Those 4 moons formed with the planet. All the other moons that we see around Jupiter are captured asteroids. And so they're not natural to the Jovian system, so to speak. So it is interesting in that, and it does keep changing. It's just as our telescopes and our satellites and technology gets better and better, we keep discovering more. And I'll hand it back to Heather.
Okay, Dr. Teets, are you with us?
I am, yes.
Did he already answer why is the comet? Yes, he already answered that. Okay. Next question is to Jeremy Veldman out of Memphis with the Memphis Astronomical Society. Where do you recommend going? Not your secret astronomical society place, but where do you recommend just the general public going to get a good view of the night sky?
Okay, so there are a couple of choices. Lake Arcabutla in Mississippi, it's about a 30-minute drive straight south from Memphis is a good spot. I was there last night viewing the comet for the last time. So it's near Hernando, Mississippi. And then if you go east in Mississippi, northern Mississippi, along Highway 302 toward Michigan City, that's where our dark sky observing site is. It's private property, unfortunately, but there are some good spots there to do dark sky.
Thank you, Jeremy. Okay, I've got one for John. John, can you tell us again a little bit about your website and kind of what you do, and give us some stuff to write down so that we can visit it later? Thanks.
Well, alrighty then. I got better for you here. We'll just bring it on up on the YouTube right there. I do a channel on YouTube called At the Eyepiece, and you can head on over there. As you can see, there are quite a few videos that I do from my live streams, where you can, I just cover everything from, like we did tonight with globular clusters live. We do galaxies live, which are ultra cool, just to be able to see a completely other galaxy. Nebula, you name it, I try to cover it from time to time. So just roll on over to YouTube. At the Eyepiece is the channel, and subscribe to that, and I guess you can get alerts on when I go live. So head on over there. Quite a few things, as you can see, that we have one up. All right.
Okay, Adam, you're really going to like this one. Okay. How are moons discovered?
How are moons discovered? That is a good question. Obviously, the ones that we can't see normally with just a normal telescope, but it depends on what discovered it. It could be from a satellite that's actually orbiting the planet, and they will see basically in the background a dot that's moving from one image to the other. A way of doing so, but I would say is not common, is what's called perturbation, which is the gravity of a moon affecting the planet that it's orbiting, and that the planet would do a slight wobble, and which is the same method in which astronomers are using to detect planets around other stars. Planets don't give off, they don't emit light, they just reflect light, but they're incredibly faint compared to the star they're orbiting. But you'll see the star kind of wobble back and forth. Well, why is it doing that? That's because there's a planet orbiting it and tugging on it slightly. I'm exaggerating the movement here with my hands. We're talking microscopic, tiny little variations. But more than likely, it's probably just when you compare one image to another of the same part of the sky, and you see a dot in one part of the sky and then you see it in another. Once you get at least at least three images like that, you can actually calculate the path of that object, and then you can figure out, yes, it's a moon orbiting that planet. And so I would say that's probably the most common method with that. So I'm going to give it back to Heather.
Okay, so I think our final question tonight was, what is everyone's most awesome astronomical sighting? And I have to say something for me. I can't just let everybody else talk. And for me, it was back in August of 2017, we had 2,500 crazy people in Warner Park, and we were all watching the solar eclipse. It was amazing. We only had 25 seconds of totality here in the park, but it really did happen just like they talk about. Venus came out, the birds started going crazy. It was just the coolest thing ever. And I hope that if you all are able, follow on Facebook the Great American Eclipse Facebook page, and it gives you all kinds of information about the upcoming total solar eclipse. Yes, there's another one. Who wants to go next?
Sure, I'll go next. And actually, if you wouldn't mind, I'm just going to share my screen for just a second, because I also want to echo that the 2017 eclipse was by far, it took the cake for me. But to go back to your point of the 2024 eclipse, so if you're in Nashville, you won't get to see totality, but you don't have to drive far to be able to see totality. Here is the path of that eclipse. So it's just going to skirt the northwest section of Tennessee, and it'll go, come up from Mexico, go on up through the northeast here. The moon is a little bit closer to the Earth during this eclipse, which makes it appear just a little bit larger. So totality in the best spot, which is somewhere right around in here, will be at about 4.5 minutes. So again, you don't have to drive far, but if you saw the first one, you know that you're going to love to see it again. And if you missed the last one because of the clouds getting in the way, then definitely check this one out, because the next time a total solar eclipse will come through the United States after this one won't be until 2045. So not far to drive, so definitely make a day trip out of it. Anybody else?
I guess I'll go next. Can everybody hear me? Solar eclipse would definitely be number one, but let me tell you, had a lot of great experiences at our dark sky site. My buddy Brian has a night vision eyepiece, and I have a 20-inch Dobsonian telescope. You can see structure in M1, the Crab Nebula, as well as the arm structure in M51, the Whirlpool Galaxy. It's cheating a little bit, but it's really cool to see, along with the Horsehead Nebula. So I've got many.
I can go. I, have to steal and echo everyone's story. We were in the stadium at Tennessee Tech University with 10,000 people cheering. And when everyone went crazy when the sun came back out, it was just an amazing experience. But, in terms of before that, the first time I saw Saturn through a telescope with my own eyes was definitely pretty much a life-changing experience, where I didn't really believe that it was there, I guess, until I really saw it. So that was really fun.
Yeah, I would echo almost everybody that the eclipse was the most amazing thing. And I've been teaching about astronomy for many, many years at the university, and I've been telling people, we've been studying eclipses and saying, there's one coming up, and then it was here. It was just amazing. But the other thing that really amazes me is looking at galaxies. That was mentioned before, but thinking about the time it has taken for the light to get from that galaxy, even the closest, the Andromeda Galaxy, it's taken the light millions of years to get to us, and thinking about what was happening here on Earth when that light left, it was pretty amazing. So that kind of always amazes me, the distances involved and the scale of things.
Yeah, I guess John here. I'll go next, and mirroring everybody else, this is the this was the eclipse. I captured these with a hydrogen alpha scope up in Portland when I was observing it up there, and that certainly has got to be ranked up there as one of the most memorable. But the planet Jupiter for me is where my love of the night sky started. So I got to say Jupiter too, because this is a video back in 2010 when Jupiter had a complete belt disappear on it. There's two main belts, North Equatorial Belt and South Equatorial Belt. Somebody correct me, or I'm not sure which belt disappeared in this period of time. But it just goes to show you how cool Jupiter is. I mean, you've had comets smash into this thing. You have periodic instances where you have the moons and the shadows go ahead and transit over the planet as well. So Jupiter changed my life, but the eclipse ranks up there.
Okay, so behind the scenes all night tonight has been Theo Wellington, and I'm going to get out of her space because we're not masked.
That's right. So I'm going to be a little bit geeky and say that I really enjoyed the transit of Venus, partly because I did so much work on the history of it leading up to that, and I did a number of talks on it. I was fortunate to see both parts of the two transits that were in 2012 and 2004. Those were only the 6th and 7th transits ever witnessed by human beings deliberately. So it's an excruciatingly rare event. So I felt really amazed to be part of that, and I really enjoyed it. And at the very end of, we didn't get to see the whole transit, but we saw it till the sunset. And right at sunset, you could look at Venus through the windows of the Science Center. It was really dimmed out by the atmosphere, and you could actually see Venus against the sun. And that was just a wonderful sight to see. So I was really thought that was cool. I mean, eclipses are cool. You have to rank those. And I'm looking forward to 2024. I think I'm headed to Texas, but anyway.
Carbondale.
She wants to, that one's Carbondale, but you know, it's April, so I don't know. I know where I won't be is Cleveland. Okay, Buffalo gets it too, and I wouldn't be in Buffalo either. But thank you all for sticking with us and for, you know, we had to do this once to get the learning experience in, so I'm glad we did. Anyway, let's see. Dave, do you have a favorite moment? You might need to unmute Dave.
You talking to me? Okay. Well, let's see. Mine, yeah, I did say the eclipse was great, and it was. It was my first eclipse. I mean, I've always been locked into doing planetarium shows, interpreting an event that I've never seen. So back in August of 17, I got to see an actual solar eclipse, and it was spectacular. When the moon finally covered the sun, it was like the hand of God flicked off the light switch, and the universe just became such a new place, with Venus appearing in the sky looking silvery white. That was awesome. But there was another event that kind of rivaled that, and I would date myself to talk about it, but it was somewhere in the mid 1960s. I happened to be a witness of one of the semi-famous fireballs that came up along the East Coast, and it went due north from south, and it was apparently skimming the atmosphere, and almost overhead, about 80 degrees from vertical, it swooped down as we rushed outside to take a look at it, and who knows, it could have been the end of the world for us for all we knew. And then it just seemed to swoop right up over our left shoulders, going almost due north, and then we heard sonic booms, and that was it. Like I said, I'd have to look it up to find what date that was, but I believe it was the maybe slightly toward the latter part of the 1960s. But also I had this screen share I wanted to do with you. I happened to get up in the morning just a few days ago, and before the sun rose, and I happened to catch the moon and Venus up there. So like I said, I'm a big fan of people just looking up. You can see some amazing things. And let's check that other picture if I can. It might be slightly clearer, I'm not sure. It might be worse. Okay, that's the other one. No, it's worse. I picked the right one. So I'll turn it back over to you.
Thank you, Dave. Thank you, everybody, for being here. We had one more comment from a visitor. It was to share the link to Through the Eyepiece. It's not Through the Eyepiece. I went to that link. Don't go there. It's at the Eyepiece. So remember that. And I did put the link on the Warner Park Nature Center Facebook page. So you can go directly to it. You can talk to John. He's got podcasts on there. It's terrific. I have to give a lot of thanks to everybody that's on my screen in front of me. But again, I want to thank Friends of Warner Parks for providing the Zoom platform, Metro Parks, Warner Park Nature Center, especially Rachel Anderson and Vera Volbrecht for providing technical assistance for us. Bays Mountain Park and Planetarium, Barnard Saferd Astronomical Society, Tennessee Tech University, the Physics Department, Pink Palace Museum of Science and Natural History, and of course, Theo and Nathan Wellington for being here tonight. This is going to live on the Nature Center YouTube channel, so you can visit it anytime. All of these places that you've seen here tonight are located within your state. So go visit them, support local, buy local. I hope to see you here at Warner Park Nature Center soon, and have a good evening.